Okay, let's start with the redox reaction. Today we are going to start with the chapter number 7, which is the redox reaction. Okay, what does redox mean? We studied about this chapter in the previous class, so who will tell me the redox reaction? What are redox reaction? Yes,
redox reaction is when oxidation and reduction take place. This reaction
Okay, one by one. Yes, Asal Islamic, what is redox?
when oxidation and reduction take place. This reaction called the redox reaction.
Yes, when oxidation and reduction they are taking place at the same time, they are called as redox reaction. Okay, we have many types of reactions. In the last class we studied about neutralization reaction, precipitation reaction and redox reaction. Who will tell me what are neutralization reaction? Yes?
Alambek, please.
When acid reacts with its bases and salt and water.
Okay, so why it is called neutralization? Yes, the pH of neutral, so that is why the pH is 7. So as a result of these acids and base reaction, they produce a neutral salt, that is why they are called as neutralization reaction. Okay, next the type of reaction which we studied in the last class, that was precipitation. Who is going to tell me about precipitation reaction? Yes, Molenbeek, can you please tell me? Islamic. Yes, what is precipitation reaction? What are precipitates?
Insoluble.
These are insoluble product, fine, and we represent them with PPT. They get settled down. Yes, they settle down at the bottom. Like let's suppose we take silver nitrate. We take what? Silver nitrate, and we add this to, let's suppose, sodium chloride. So it is going to produce silver chloride and sodium nitrate is produced. Sodium nitrate is going to be in the soluble form and silver chloride will settle down, and it is represented with this downward headed arrow, and we call it as, in a simple form, PPT. This is an example of precipitation reactions. Understand? Okay. Now, the third type of reaction which we are going to study in detail in this chapter, these are redox reaction. And as Islamic told that these are the reaction in which we are studying about oxidation and reduction simultaneously. And what does simultaneously mean? At the same time. This is called as redox reaction. Now, in the last class we studied about oxidation in terms of hydrogen, in terms of oxygen, in terms of electron transfer. Okay, let's have a look. Oxidation. Oxidation we can define in 3 terms. In terms,
Please.
in terms of hydrogen, in terms of oxygen, in terms of electron transfer. Okay, when we are defining oxidation in terms of hydrogen or oxygen, that is old concept, and when we are defining oxidation and reduction in terms of electron transfer, that is a modern concept. Now, who will tell me oxidation in terms of hydrogen? Big. Loss of hydrogen. Loss of Hydrogen is what? Oxidation. Okay, who will tell me in terms of oxygen? Yes.
Gain of oxygen is oxidation. Loss of oxygen is reduction.
Wait, just the thing which I asked you, answer me that thing. Fine. The gain of oxygen is what?
Oxidation.
Oxidation. Very good. Okay, who will tell me in terms of electron transfer? Who are here second study the names?
Scrub please.
Sohrabik. Where is he? Very good. Okay, loss of electron is what? Oxidation. Okay, so let's revise it once again. Oxidation in terms of hydrogen is the loss of hydrogen. The gain of oxygen is oxidation. And loss of electron is oxidation. Today we are going to start with now a new topic. Over here you can see we have magnesium that is being reacted with oxygen, molecular oxygen, to produce magnesium oxide. So how this has been taken place? In magnesium, you know what is the atomic number of magnesium? What is the atomic number of magnesium? That is atomic number or atomic mass? Mass. I'm talking about atomic number. Can you see here? Just sum these. 12. 12. Fine. So what is the behavior of the magnesium? Magnesium is going to lose its 2 electron to look like the noble gas, to gain the stability like the noble gases. So it is going to lose its 2 electron, and as a result magnesium will get a charge of +2. And what oxygen? One atom of oxygen. What is the atomic number of oxygen? Can you please tell me, anyone? 8. So oxygen needs 2 electrons further to gain a stability like the noble gases. So as a result, we will have a negative charge on oxygen when it will gain 2 electrons from outside or from the magnesium. So now we have a positive magnesium with a +2 charge, and oxide ion has been created with a -2 ion. So what will happen here? They will make a bond, and as a result, what will happen? An ionic compound is formed because there is loss and gain story. And you know what are ionic bonds? When there is loss and a gain between 2 atoms, it leads to the formation of ionic bond. Now over here, can you please tell me which one is oxidized and which one is reduced? As we studied the oxidation and reduction in terms of electron transfer. So who will tell me magnesium here is oxidized or reduced? Yes. Magnesium is oxidized and oxygen is reduced. You have to say like these, fine? Like this. Magnesium is oxidized and oxygen is reduced. In oxygen there is a gain, and in magnesium there is the loss. Yes. So if a substance loses electron during a reaction, it is said to be oxidized. You can see this word. And if it gains electron, it is said to be reduced. So we are going to classify this magnesium as what? As an oxidized species, and this oxygen as a reduced species. Got it? And as a whole, this formation of magnesium oxide has taken place by which type of reaction? By a redox reaction. Is it easy now? Have you understood, all of you? Any question here? Okay, we have a point here which is written oil rig. You know oil? Oil is the word used for oxidation, is the loss of electron. You have to remember this. And reduction is what? It's a gain of electron. So in this reaction, in the formation of a magnesium oxide, here we have one of the species is getting oxidized, another is what? Reduced. Let's move to the next slide. Okay, Over here we have to discuss about how to write a half equation of the redox type of reaction where there is electron transferring. You know, we discuss about the redox reaction in terms of hydrogen, in terms of oxygen, and in terms of electron transferring. But in our further lesson or in our topics, we are not going to discuss in terms of hydrogen or in terms of oxygen, because those were old concepts. We have to be now stick to just to the electron transferring concept. So let's have a look. The magnesium, what has happened here? There was a loss of electron because magnesium 12 was changed to magnesium 10, and in case of oxygen, the oxygen 8 has gained 2 electron and it has changed to 10 electron. So now what will happen over here, if I am taking, because oxygen in the nature, that is always present in which form? In the molecular form. You can get oxygen in the free form in which form? In the molecular form. You can never have oxygen in the atomic form. So if I take oxygen in the molecular form, how many electrons I need to convert into an ion? Yes? If one oxygen atom needs 2 electrons, so 2 oxygen atom needs how many? 4 electrons. So you just have to put 2 atoms of oxygen will gain, each oxygen is going to gain 2 electrons by any other species to change into an ion. Got it? Okay, how to write their half equation? You can see over here 2 magnesium atoms, they will change into positive ion by how many loss of electron? By each. And by 2 magnesium atom, how many electrons are lost? 4. 1 magnesium atom loses how many electrons? 2. 2 magnesium atom will lose how many electrons? 4. Okay, and these 4 electrons will be captured by molecular oxygen, and as a result they will convert to 2 atoms of ionic oxygen. Understand?